Have you ever noticed how your toys just sit perfectly still on the floor? Whether it's a car or a block, it stays exactly where you left it. It won't move an inch all by itself. So how do things finally get up and go? What has to happen to make a toy start moving across the room? To get anything moving, you have to use a force. You can't see a force, but you can see what it does. A force is simply when you give something a push or a pull. Think about your toy car. When you put your hand behind it and give it a nudge, you are using a push to make it zoom forward across the floor. It's the same when you play with a wagon. When you grab the handle and walk away, you are pulling it along behind you. Let's try something. Pause the video for a moment and tell your teacher or parent about one time you pushed or pulled something today. I'll be right here when you get back. Everything in the world that moves, from a tiny marble to a giant truck, needs a force to start. These same pushes and pulls have other jobs too. They help us control exactly how fast or slow things go. If you want a ball to move really fast, you give it a stronger push. Like when you kick a soccer ball across the grass. The harder you kick, the faster it flies. Pushes can also make things stop. If a ball is rolling toward you and you put your foot on top of it, you are pushing down to make the ball stay still. Whether something is zooming at top speed or freezing in place, a push or a pull is the reason why. Sometimes how something moves depends on what it looks like. The shape of an object changes how it reacts to our pushes and pulls. Imagine two things sitting on a table, a round toy car with wheels and a flat, heavy book. If you gave the book a gentle push, do you think it would roll away as easily as the car? Take a second to think about what would happen. The book is flat, so it would just slide a little bit and then stop. But the toy car is shaped to roll, so the same little push sends it much further. To get a smooth, easy ride, a force needs to work together with the right shape. Now, let's look at something that seems almost impossible. We know that heavy things usually want to fall straight down to the ground. Think about a toy boat in the bathtub. Even though it has some weight, it stays right on top of the water. But what about a giant cargo ship out on the ocean? Those are made of heavy metal and carry thousands of tons of weight. If the ship is so big and so heavy, why doesn't it sink straight to the bottom? The secret is in the ship's special shape. If we could look inside a ship, we would see that the bottom is very wide and mostly hollow, like a big empty bowl. Because the ship is so wide, all that heavy weight isn't pressing down on one tiny spot. Instead, the weight is spread out over a huge area of water. Because the weight is spread so thin, the water underneath is strong enough to push back. It pushes up against the bottom of the ship with its own force. The weight pulling down and the water pushing up are perfectly balanced. This balance is what lets a massive ship float safely across the sea. You did it. You figured out how pushes, pulls, and shapes all work together to make things move, and even keep them floating. Forces are all around us. Every time you move a toy or see a boat on the water, you're seeing the magic of motion in action. Keep exploring.